Hello, folks. What's up? Welcome to the University of Regina. My name is Jinkai Xue, Assistant Professor in Environmental Systems Engineering of the University of Regina. Today, I'm bringing you guys my research theme, Future-Ready Water Resource Recovery in Cold Climates. We all know that water is essential to life on Earth, right? So it can be used for energy production, and also when we treat water or wastewater, it will consume energy. Water is also important to the environment. Without sufficient and clean water, environmental health is at stake. It also requires water to produce food, and it's important for animal and human health. When there is water shortage or pollution, life becomes harder. Therefore, water, energy, and health form a very close nexus. I call it now. In fact, you can find that water is directly or indirectly related to many of the 17 Sustainable Development Goals set by the United Nations. It's essential to the well-being of human race. There are a number of water issues in the modern world, such as water scarcity, pollution, flooding, and inequality. Wastewater plays a very important role as it is the major source of natural water pollution, and it is contributing to freshwater shortage. But wastewater is complex and not easy to handle. In Canada, the major wastewater challenges are as follows. First, inadequate, aging, and outdated infrastructure, especially for the smaller and remote communities, such as the First Nations communities, and a higher carbon footprint, because the traditional wastewater treatment facilities require a lot of energy consumption. And of course, it emits, right, contribute to the greenhouse gas emission. And most of the current wastewater treatment processes are actually diverting pollutants rather than completely removing the pollutants. So it's basically transferring the risks from wastewater to probably soil and other places. And another challenge is the emerging or unregulated pollutants, such as microplastics, PFAS, pharmaceuticals, and so on. So these pollutants are usually trace in concentration, and they are recalcitrant to the traditional treatment processes, such as biodegradation, and they are less biodegradable. And another issue is the minimum recovery of valuable resources, including water, nutrients, energy, etc. In Canada, we do have another challenge, which is the harsh winter time, and the low temperature is really not favorable for wastewater treatment. So to achieve future-ready wastewater management, the wastewater treatment facility should really be more resource conscious, smaller, and future-ready. So you should be aware that there are many different types of wastewater, not only household or domestic wastewater, but also there are other types, and each of them has their own characteristics and corresponding challenges. For municipal wastewater, there are nutrients, personal care products, drugs, pathogens, and so on. For industrial wastewater, there are many different types of industries, right? And of course, there will be different industrial wastewaters, and mostly they contain higher concentrations of organics, nutrients, hydrocarbons, heavy metals, salts, and so on. And of course, there are also landfill leachate, because we are managing our solid waste or garbage by landfilling, and these landfilling sites will produce a lot of polluted water. And this kind of leachate wastewater contains higher persistent organic pollutants, pathogens, heavy metals, and nutrients, and so on. And of course, agriculture is a very important sector in Western Canada, right? And the agricultural wastewater, such as livestock wastewater, and it might contain higher concentrations of organics, nutrients, pathogens, and so on. So without proper treatment of these wastewater, it will be a threat to our environment and public health, and of course, economy. But because of the difference, or because of the uniqueness of these wastewater, there is no silver bullet for these all the wastewaters, And therefore, case-specific optimization of the system design and operation is required. So on the other hand, wastewater contains a lot of valuable resources, including water, nutrients, energy, biopolymers, and so on. And these resources could be recovered for multiple beneficial purposes, such as fertilizers, right? Water for irrigation purpose, and also bioenergy production. Such a integrated wastewater management paradigm is called future-ready water resource recovery. And the traditional wastewater treatment plants should really be rebranded as water resource recovery facilities, or WRRF. So to actualize these co-benefits of wastewater management, a range of expertise can be used, or a range of technologies can be used, right? These methods could be categorized into 4 groups, including physical, chemical, biological, and hybrid. For physical methods, there are membrane filtrations, granular media filtration, and so on. For chemical methods, there are coagulation, advanced oxidation, and so on. For biological methods, there are biofilms, anaerobic digestion, and so on. For hybrid systems, they can be a combination of multiple different methods, such as membrane bioreactors, which is actually a combination of membrane filtration and biodegradation, right? And ozonation biofilm reactors, which is the combination of ozone treatment and biofilm reactors. For example, here we have a conceptualized hybridized water resource recovery system that can be installed for a single household. It consists of absorption, ultrafiltration, and UV disinfection. The entire system can be powered by solar energy and can be controlled by artificial intelligence. To make it cost-effective, the system design and operation should be optimized for maximizing treatment efficiency and minimizing financial and environmental costs. So you might have noticed that in solving wastewater challenges, a spectrum of expertise is required, right? Such as environmental system engineering and software systems engineering, and of course, economics. You absolutely want your technology to be cost effective, right? Therefore, our research requires, interdisciplinary collaboration, and most importantly, you. So thank you very much for your attention. More information is available on my lab's website. Thanks.